I'm going to take you through how we would define what we call the trigonometric ratios or the trigonometric functions. Those are two names just for the exact same idea. Now, if you've never seen that word before, trigonometric, you might think that's a big scary word, but essentially it's just made up of bits that we already know. So hopefully if you've heard of tricycles or triangles, then that part tri is not going to scare you off. That just means 3. And because that means 3, a trigon is just another name for a triangle. It's a 3-sided polygon. Just like we have pentagon, hexagon. A trigon is the same idea. So that's just a 3-sided polygon. And then the word metric here, you'll have seen before. It's the metric system, for example. It just means measure. So when we talk about trigonometric, we just mean measuring 3-sided shapes. So we're measuring triangles. And then when you've got the word function is a very important word in maths that I'm not going to spend too long on now. But ratio in this context just means fraction. So the trigonometric ratios are just fractions that we use to measure triangles. Now, before trying to understand how any of this works, you would need to know how to label a triangle using the technical terms hypotenuse, opposite, and adjacent. Because once we've got those measurements, we can use them to define what we then call the trigonometric ratios. These fancy names that we're coming up with for fractions involving these 3 sides. Now, it's important you appreciate that these aren't just things we're making up. These are just names we're, as far as you're concerned, pulling out of thin air that then happen to be useful. So there's nothing at this point fancy or technical going on. I'm just going to say that if I have the fraction that is the opposite length over the hypotenuse, I'm just going to call that sin of theta or sine of theta. So that theta, the fact I'm using that theta is just to remind me that this depends on the angle, because you'll remember that this wouldn't be called the opposite if we were talking about a different angle. So that theta is just to remind me that we're talking about the angle. And so I'm saying that sine of the theta, if I do sine with this theta, then that's the opposite over the hypotenuse. And we have similar ideas for other fractions we can make here. So another one I can make is adjacent over hypotenuse. We call that cos, which is just short for cosine. So we've got the sine and the cosine. The reason those two have got such similar names is that they're actually very, very closely related, which we are going to see quite a lot in further topics, that sine and cosine are very, very closely related. And then you've got the last one, which is related to these two, but perhaps not quite as closely. It's almost like these two are brothers, and then the last one is a cousin. But this is what we call the tangent function, so the opposite over the adjacent. Is the tangent function, which we shorten to tan. So these are just 3 statements that we can make using fractions of this triangle. Sine of theta is opposite over hypotenuse, the cosine of theta is the adjacent over the hypotenuse, and the tangent of theta is the opposite over the adjacent. If you're already thinking this is quite a lot to remember, then have no fear. There is a nice little mnemonic you may have heard of before, because people do chant it rather a lot, that we use to help us remember these 3 definitions. And so we have Sohcahtoa is how we remember these functions. Sohcahtoa. So we've got here sine of theta is the opposite over the hypotenuse. cosine of theta is the adjacent over the hypotenuse, and the tangent of theta is the opposite over the adjacent. Sohcahtoa. And this is quite an easy thing to remember once you've used it a few times, which means that this entire setup is quite easy to remember once you've done it a few times. So these are just fractions that we've named that then turn out to be useful. Here is an example of a triangle. Now I want to be very clear, this triangle doesn't quite exist. This is a hypothetical imaginary triangle. It doesn't quite exist. It very nearly does, it's just that this isn't exactly 37 degrees in the real life triangle. It's something very close to 37 degrees. Which means that we're not going to worry too much that this isn't quite a real triangle, because to a certain number of decimal places, this will be fine. Now, once I've got a triangle like this, I want to make sure I'm labeling my sides correctly. That's the important thing we learned to do. So I can see that this is definitely the line opposite the right angle, which means that that's my hypotenuse. Then I've got the other line that next to the angle is the adjacent one, and we have the opposite length there. So I can use Sohcahtoa to define these things I've just came up with. So I can tell you that sine of 37 is the opposite length over the hypotenuse. So sine of 37 is 3/5, approximately. I can also do the same thing with cosine. So cosine of 37 is the adjacent over the hypotenuse, which is 4/5. And finally, the tangent of 37 is the opposite over the adjacent length, so that's 3/4. So you can see how I've used this triangle to come up with these three statements, these three essentially definitions for what we're talking about. Okay, there is a next bit of work we need to do on top of this. So we've just put a lot of effort into defining the sine, cosine, and tangent functions. So now we're going to define their opposites, their inverses. Whenever we're talking about functions, whenever we're talking about doing something, we are normally concerned with, well, what's the opposite of that? So, for example, it wouldn't have taken you long in primary school. After you learned what adding 5 was, you would have then learned about the opposite of that, which is taking away 5. And so, as soon as you learned about timesing by 7, you would have learned about the opposite, which is dividing by 7. We have these inverses in maths is a very, very important idea. So we're going to define the inverses of these three functions. So here's our first inverse. We say that theta is the inverse sine of the opposite over the hypotenuse. So what we're doing here is we are undoing the signing to just get theta on its own. In the same way that we normally balance equations, we do the same thing to both sides. So if I unsigned this side, then I would just get theta, and if I unsigned this side, I get the inverse sine of the opposite over the hypotenuse. We do have different names for these things. So you may hear it called the A sine, or the arc sine, or the inverse sine, or sine to the -1. That last one is my least favourite. It is what's going on, because it's what we write down, but it's not actually a power at all. That's not to the power of -1. That's not what we mean. What we mean is we're unsigning. So I often use the phrase unsigning. That's not actually a technical term, but it's what I use. Inverse sine would be my go-to preference here, because that reminds me exactly what's going on. I'm doing the inverse operation of sine. And I hope it comes as no surprise to you that we can do the exact same thing with the other functions. So the inverse cos, or the inverse cosine, is this one. And the inverse tangent is this one. So to untan what's going on over here, we get to this. Let me show you how that works in practice. So we'll go back to our not technically a triangle, but close enough shape over here. And I will once again label my sides, as I am now getting quite good at. And I'm going to remind myself of Sohcahtoa because it's useful to have that memory aid just to help me out with my functions. So last time we agreed that sine of 37 is 3/5. Now with our new notation, we can write that exact same statement in just a slightly different way. So I can say that instead, 37 is the inverse sine of 3/5. So this is exactly the same thing. This is saying exactly the same thing as it did on my previous slide. I've just written it in a different way. So 37 is the inverse sine of 3/5. 37 is the inverse cos of 4/5. Again, I'm using my CAH, I'm using my cos of theta equals adjacent over hypotenuse. So cos of 37 equals 4/5, which means that 37 is the inverse cos of 4/5. And finally, it is also true that 37 is approximately the inverse tan of 3/4. So just to put it all on one page so you can see the comparison here. If I know what sine of something is, then the inverse sine is just undoing it. So what we have here is we have 6 very nearly true statements that we have formed using these functions. Now, as it turns out, these functions turn out to be really useful. At the minute, it all feels very arbitrary, it all feels very random, I understand that. But we use this in a lot of different situations. So you need to be comfortable with how these definitions work. The key points from this video. The sine, cosine, and tangent functions are defined using the sides and angles of right angle triangles. We use Sohcahtoa just to remember the formulae. That's its only purpose, is it's a memory aid. It helps us remember those functions that we just made up. And the inverse trig functions, as we sometimes call them. I'm using trig here as a short version of trigonometry. So these functions undo the original trigonometry functions.